Hey, Global Impact students, this is Mr. Ellinger. This lesson is on conditional probability. Our learning targets for the lesson, we want to be able to find conditional probabilities, and we also want to be able to use tables and tree diagrams to determine conditional probabilities. Essential understanding. A conditional probability is the probability that one event occurs given that another event has occurred. So the probability that an event B will occur, given that another event A has already occurred, is called a conditional probability. Conditional probability exists when two events are dependent. One event depends on the other. The outcome of one depends on the other. You write the conditional probability of an event B, given that event A occurs, like this. P, and then in parentheses, B, vertical bar, A. Okay, so again, this is read the probability of event B given that A occurs. All right, so we have these things called contingency tables that we can make, or they're also called two-way frequency tables. Frequency table that contains data from two different categories. Contingency tables and tree diagrams can help you find conditional probabilities. All right, so here we have a problem. The table shows students by gender and by type of school in 2005. You pick a student at random. Okay, so here we have this table. We have males in thousands and we have females in thousands. 2-year colleges, 4-year colleges, and graduate schools. So it tells us how many males and how many females are in these different types of colleges. So we're choosing a student at random. So in A, it's asking us what is the probability that you choose a female given that the female is in graduate school. Okay, so the condition that the person selected is at graduate school limits the sample space to the 3,303,000 graduate students. Okay, right here it's a combination of these two. So out of these graduate students, these are female. Okay, so 1,954,000 are female. And again, this is in thousands. So we need to take this, tack on 3 zeros because it's in thousands, and we have our actual value. Okay, so what is the probability that we have a female given that they're in graduate school? Well, it's 1954 over 3303, which is approximately 0.59. Okay. And if you notice here, we have these two values in millions. We have these two values as they are in the table. And that's okay, right? Because, we have the 1954 over 3303 here. The actual value of those is 1954000 over 3303000. But we could divide the numerator and the denominator by 1,000, which would really essentially be multiplying the whole ratio or fraction by 1. So really essentially what we can do is cancel the zeros and just work with the part that they're showing here, okay? So in part A, what is the probability that you choose a female given that they're in graduate school? You have almost a 60% chance of that, 0.59, okay? The second part, what is the probability that the student chosen at random is a female? Well, we need to figure out the total number of females, so we're going to add this value, and this value together. That's our numerator here, our top of our ratio, over the total number of students. So take all the values in the table, add them all together. That's your denominator, or the bottom of your ratio. Okay, and go ahead and divide those two, get a decimal, and you get a probability of 0.57, or 57%. Okay? So a follow-up to this problem, what's the probability that you choose or select a 4-year student given that they're a male? All right, well, what we have to do is we have to say, okay, how many 4-year students are there? 4,324 times 1,000, essentially. Given that they're a male, we need to figure out how many males there are, so we need to add this plus this plus this, and that is a value of 7,539,000. Divide that out, we get 0.57 approximately. So that's our probability. Okay, In part B, without calculating, given a student is enrolled in a 4-year college, is it more likely for the student to be male or female? Explain. So without doing any calculations at all, which one's more likely? A student chosen at random in a 4-year college to be a male or a female. Well, 4-year college, we have 4,324 males. We have 5,514 females. There are more females than males, so it's more likely that it will be a female. There are more females enrolled. Okay, so we're looking at conditional probabilities here, and this is kind of the formal definition of a conditional probability in the box here. So you can take a look at that. Let's look at another example here. Researchers asked shampoo users whether they apply shampoo directly to the head or indirectly using a hand. What is the probability that a respondent applies shampoo directly to their head, given that the respondent is a female? Okay, so what we can write is probability of we can put shampoo to the head, our vertical bar, given that the person is a female. So the first thing that we have to do to calculate this probability is we have to look at how many females there are that apply directly onto their head, and there are 6. And we have to put that over the total number of females, which is 30. So that is a 0.20 probability, or 20%. It follows from what we were just looking at with conditional probability here, probability of B given A, and it equals the probability of A and B over the probability of A, that the probability of A and B equals the probability of A times the probability of B given A. All this is just one form rewritten. We take the denominator here and multiply it to the other side, and that's where we get this other form. So we can use this rule along with the tree diagram to find probabilities of dependent events. So here we have an example, and we have a lot going on here. Okay, so let me drop a line here just to keep it separated. Let's take a look to the left of the line here. So we have a school system compiled the following information from a survey sent to people who were juniors 10 years earlier. 85% of the students graduated from high school. Of the students who graduated from high school, 90% are happy with their present jobs. Of the students who did not graduate from high school, 60% are happy with their present jobs. What is the probability that a person from the junior class 10 years ago graduated from high school and is happy with his or her present job? So we can make a tree diagram to help organize the information. So they're saying let G equal graduated, NG equal not graduated, and H equal happy with present job, NH equal not happy with present job. So a tree diagram, when you start here, you're a student, you're a junior, you have 2 paths, right? You can either graduate or you can not graduate. And then if you graduate, you can either be, from here, you can either be happy, not happy. If you didn't graduate, you can either be happy or not happy. Okay? And that's kind of what these boxes here represent. Now, these probabilities that are in here in red, these are all based on the values in the given problem. Okay? So, what is the probability that a person from the junior class 10 years ago graduated from high school and is happy with his or her present job? So, they need to have graduated. So, we follow this path here. And happy with their present job, we need to continue on this path here. So, we're looking at these 2 values. So, the blue highlighted path there represents what we need to find out. What is the probability that they graduated and are happy? Well, we're going to take the probability that they graduated and we're going to multiply by the probability that they're happy given that they graduated. And those 2 probabilities are 0.85 and 0.90. Multiplying those 2 together, you get 0.765. So the answer to the question, the probability that a person from the junior class 10 years ago graduated and is happy with his or her present job is 0.765 or 76.5%. Okay? But again, the key is right here. This is what we're talking about. Okay, is using this formula. Right, so here we have, over here on the right, we have some follow-up questions to this situation. The first one says, the given information in the problem states the probability a student graduated high school. How is the probability that a student did not graduate found? Okay, so how was this probability found? Okay, it didn't tell us that anywhere up here. It didn't tell us that 15% did not graduate. But if 85% did graduate, then that means whatever is left did not graduate. And so what we really do is take 1 minus 0.85. And that tells us how many did not graduate. Remember that we call that a complement. So if you have the probability of something happening, 0.85, the probability of that something not happening, just do 1 minus that something and you get 0.15. All right, our third question. What is the probability that a student from the junior class 10 years ago did not graduate and is happy with his or her present job? Well, that's asking us to find this probability. Okay? That's what it's asking us. So here's what we have to calculate. Probability not graduated. We have to multiply that by the probability that they're happy given that they did not graduate. And those two values are 0.15 times 0.61. And that is 0.09. So that's about 9%. That's the probability. And lastly, if the graduating class contained 600 students, how many students would you expect did not graduate and are happy with their present jobs? We need to take a look over here. The probability that they did not graduate and are happy with their jobs is this value right here, 60%. Okay, so what we've got to calculate is we've got to calculate, okay, all right, so the way that we calculate this is our probability based on the previous answer is 0.09, right? There's a 0.09 probability of this happening. So we just take that value and multiply it by how many students we have, okay? 0.09 times 600 is 54. So that's how many students out of the 600 students we would expect that didn't graduate and are happy with their present jobs. All right, so this, again, was all about conditional probability. Conditional probability is what is the probability of something occurring given that something else has occurred. And we have two different types of problem situations that we took a look at, and we need to be able to identify both and know how to handle both. Have a good day, folks.